Okay, so the variation functions, there's going to be direct, inverse, joint variation, and then the combined variation we're doing tomorrow. So we're going to solve problems using these different types of variations, and we're also going to do some graphing. We're going to, and we are going to do this without our calculator. So for direct variation, it's a relationship between two variables that can be written as y equals kx. They're always going to tell you k can't be 0 because if it was, the equation would just be y equals 0, and then it wouldn't be a relationship between x and y. So the variable k is the constant of variation. This is a linear function. So if we look at y equals kx, the slope would be the k value. So remember, slope is m. So that's why we put m equals k. The y-intercept would be 0. And it is in the form y equals mx plus b. So you can see the k is in the place of m. There's nothing in the place of b, which means that is going to be our y-intercept. Okay? All right, so we're going to start by graphing. And they're always going to give you a sentence that explains how these two variables are related. For example, this one says y varies directly as x. So we're going to write and graph that variation function. So they're going to give you y equals 6.5 when x is 13. The first thing we're going to do is find k. So we have y equals kx because they vary directly. And then we're just going to substitute our values in. So you have 6.5 equals k times 13. All right, so to solve for k, we're going to divide by 13. Okay, and don't freak out. Yes, we're going to do this without a calculator, but is there a special relationship these two have? Yes, because half of 13 is 6 1/2. Half of 12 is 6. Okay, so this is 1/2. If you didn't recognize that right away, though, when you're doing your k value, if you had the 6.5 over 13, anytime it's 0.5, what could you multiply by to make that a whole number? 2. And then if you did that times 2 times 2, you'd have 13 over 26, and then you'd reduce it. And hopefully at that point you would realize that they're 1/2. But this is a strategy that you are going to use later on, which is why I wrote it down for you. All right, so then it says to write and graph the function. So when you write the function, it is this value of k plugged into the equation. So it's y equals 1/2 x. Okay, so this is the function. So now we're going to graph it. When you are graphing a linear function, do you guys remember where you start? When you're graphing a linear function, do you remember where you start? Okay, in this case it's 0, 0. Why? Yeah. Okay, so start at your y-intercept, 0, 0. And then we're going to use our slope. Okay, so we're going to start at 0, 0. And then your slope is 1 over 2. Remember, that's your rise over your run. So we're just going to go up 1 over 2. Up 1 over 2. Down 1, back 2. Down 1, back 2. Okay, and then we're going to connect those points. If you like the side of a folder, use that. Or even the side of a piece of paper. This is the only linear function that we're going to graph today. Okay, but it is a linear function, so it should be a straight line here. Okay, so you have the function and you have the graph. Okay, questions for me on part 1? All right, we're going to kick things up to notches with example 2. Like I said, example 2 is going to be the most intensive, and then once you do example 2, the rest are going to seem pretty easy, okay? All right, so we're talking about direct variation. So I said they're always going to give you a sentence that explains how they're related. So this is the cost of an item in euros E. Varies directly. Yana, what's the current currency in Germany?
Euro.
It is?
Yeah.
Cool. In dollars D. Have any of you guys used different forms of money? Canadian coins? I've been to Sweden and they use, they call at least part of their money crowns. So there are different exchange rates, okay? So the cost in euros E varies directly as the cost of the item in dollars D. And then they give you these values. So E equals 3.85 euros when D is $5. So those go together. Okay, here's the value for E when D is 5. And then notice there's another part that says find D when E equals 10 euros. So all this information is given to you at one time, and that can be a lot, especially when they give you two different values of euros. So remember, you have to do 2 steps. And your first step is always to find that constant K. Okay? Now when you're finding it, we're going to set up our direct variation equation, which remember, usually our direct variation is y equals k times x. But now we don't have y, it says the euros varies directly. So it's E varies directly, so E equals K multiplied by D. So it's the same setup, except instead of Y, we have E, and instead of X, we have D. And it just goes in order. So whatever's given first is your Y. Whatever's given second is your X. Okay? And then we're going to solve this for K using this pair. Okay, so we're going to have 3.85 equals K times, and then we can just leave it as 5. All right, so then we're going to divide both sides by 5. And to divide that by 5, we are going to set up long division. Okay? Like I said, this will be the most intensive part, and then I'll go downhill from here, okay? So 3.85 divided by 5. So in Chapter 3, we did some long division, but we might need a reminder of the rules with the decimal. If you have a decimal here, do you guys remember where it goes? Yeah, so it goes straight up here. And can you see that the 3.85 is less than 5? Right, so it is going to be a decimal. Okay, it's going to be less than 1. How many times does 5 go into 38? 7 times. So remember, you multiply. 7 times 5 is 35. Subtract. 38 minus 35 is 3. 5 doesn't go into 3, so we bring down the 5. 5 goes into 35, 7 times. Okay, that wasn't too terrible. So that's your value for K. So now we're going to write the equation, okay? So once you know what the K value is, it's E equals 0.77E. Okay, so for every dollar, that's going to equal 0.77 euros. Okay, that's your function. Just going to label that. Okay, now your second step is going to be to find D when E equals 10 euros. So step 2 says to find D. So we're going to use our equation. And if we were trying to find the E for this, if this was switched around and this was 10, do you guys know what happens when you multiply something by 10? Yeah, the decimal goes one place to the right. Okay? All right, but unfortunately, we have a long road ahead. Okay, so we have 10 equals 0.77D. And so we're going to divide both sides by 0.77. And we're going to set up long division for this. Okay, and this may be the most difficult thing you do. You let me know. You guys have anything difficult coming up today in your other classes? Don't know yet. Any tests, any quizzes? No? Not sure yet. Do you guys have pop quizzes anymore? Should I bring them back? Yeah. Okay, so if the decimal's on the outside, do you guys remember the rule?
Wait, couldn't you just make it 77?
Yeah, you do. You make it 77. So 1, 2, and then you just move this. 1, 2. Put the decimal here. Okay, so 77 doesn't go into 10, so let's look at 100. How many times does 77 go into 100? Once. Okay, so we put the 1 above the 100. So 1 times 77. 10 minus 7 is 3. 9 minus 7 is 2. 77 doesn't go into 23, so we, bring it down. Now let's think about this. If 77 goes into 100 once, well, what would we estimate for 230? Yeah, we'd either estimate 3 or 2. What's 77 times 2? Or 77 plus 77? Close. So the 7 and 7 is 14. 70 and 70 is 140. So 140 plus 14 would be, yep. And so that's an easy thing to say, though, because you have all those 7s in there. Okay, so 154. So let's see what the difference is. So 10 minus 4 is 6. And then that would make this a 2. 12 minus 5 is 7. Look, it was 1 off. Okay, so then 76, it doesn't go in there. And then we're trying to find the money, right? The dollars. So dollars are measured with 2 decimal places. So our journey continues. But again, let's use our estimation skills. What is 1 multiple of 77 that you know right away? Yeah, 77 times 10 is going to be 770. So we know this has to be 77 times what? 9. You guys remember how to multiply like this? So 7 times 9 is, carry the 6. 63 plus 6. 693 is what we have. Okay, and then we're going to subtract. Okay, and then you could also add up. Like, do you see how if you added this, you get 700? And then this would be the 67. All right, and then I go one more. So what would we estimate this as? So we just did 77 times 9, and we got 693, right? So this is, to get 670, it's probably 77 times what? Yeah. Okay, so 7 times 8 is 56. 56 plus 5 would be 61. Oh, now I'll put the 8 here. Okay, so then 10 minus 6 is 4. You have 54. And really, like, we'll need this one to do the rounding, but in terms of the rounding, if it's 540, right, we know that this is going to be at least 5, right? Because 77 would go into 500 at least 5 times, right? So if this is 5 or above, what is that going to round to? Yep, so 1299. Okay, so I'm telling you that it would go in there 7 times, but really, using your rounding rules, you would know that that is. All right, you did it. You did the hardest thing you're going to do today. Dividing decimal on a calculator. So it's going to make example 3 look pretty good. A lot of our examples today are actually going to be related to geometry. So example 3, you have the perimeter of a regular dodecagon. Do you guys remember anything about a dodecagon? How many sides it has? No, but you're close. So decagon is 10. What is the do? 12. You know 8. 8 would be a what? Yeah. Do you guys remember the 7 and the 9-sided ones? Heptagon is 7. What about 9? Yeah. Yeah, good. All right, so this is the perimeter P. Varies directly as the side length S. And you're given P is 18 inches when S is 1.5 inches. And I'm going to have you guys start this one by yourself. Okay, so there's 2 steps. So I want you to do the first step. Okay, so write out your equation. Alright, let's see what we plugged in. So remember, your first step is finding K. And one thing I always suggest is rewriting this with the variables that they give you. Okay, so you're going to find K, and this is the perimeter P, varies directly, so K times the side length S. Okay, so your value for P is 18, and then S is 1.5, so you're dividing both sides by 1.5, and you can absolutely do long division, or remember, like I told you, if you have a decimal that ends in 5, you could just do what? To the top and the bottom. Yeah, if you multiply by 2, right, then 2 times 18 is, yep, so it'd be 36 over 3. What's 36 divided by 3? Yeah, see? That's not too bad, right? Compared to the last one, it's smooth sailing. Alright, so here's your function. And you would still get 12 if you did long division. Okay, so that's fine too. Whichever one you want. And then your step 2, now you have to find the value of S. Okay, so you have to use this equation. P equals 12 times S. Okay, so 75 equals 12 times S. So we're going to divide by 12. And I would just try to reduce this. Right? What goes into both 75 and 12? 3. What's 75 divided by 3? 25. 12 divided by 3. How many times does 4 go into 25? 6 with how much left over? Yeah, so you could do 6 1/4 inches or 6.25 inches. Okay, either one would be fine. It doesn't say like what to round to or anything. Okay, so either one of those would be great. All right, questions for me on those? Didn't that one feel a lot better than example 2 in terms of how to simplify without your calculator? Yeah. All right, so the next type of variation, remember we're learning 3 types today, This one is called joint variation because you're going to have two variables on the right-hand side, three variables altogether. Okay, so this one is with y, and it says if y varies jointly as x and z, it can be written as, and it's y equals k times x times z, but we're going to write that out all together in this box. And then the variable k still represents that constant of variation. So when you see this all together, it'll just be k x z. Okay, and this is joint variation. So these boxes will be helpful when you're doing your practice problems. All right, and more geometry stuff. We're going to be talking about the volume. So the volume V of a cone varies jointly as the area of the base. Do you guys remember that that's a capital B? It's the area of the base B and the height H. Okay, and then we're going to fill this part in together, and the volume would be 12 pi feet cubed. So your final answer is going to have units on it. You do not have to plug the units in when you're solving. In fact, I recommend not doing it because it just adds more letters and numbers. Okay, so you have the volume and the area of the base, and the height is 4 feet. And then you have to find B when V equals 24 pi feet cubed, and the height is 9 feet. Okay, so remember, they're going to give you all this information at one time, so you have to pick out what you're using for step 1. Luckily, it usually goes in order. So when you're trying to find K in the first step, you can use what they give you first here. They'll give you all three things so that you can solve for K. So the volume V, so V equals, and it varies jointly, so I'm going to put my K in there, and then it's going to be times B times H, so B and H. So now I'm going to substitute. So this is 12 pi. I do have to put the pi in there. And then I have K, 9 pi times 4. Now when you're solving, there are a couple different ways to do this. I always recommend simplifying this side first, so multiplying these together. So 9 pi times 4 is 36 pi. And that's still times K, and then this is 12 pi. Okay, so if I want to get K by itself, Brianna, can you tell me what I want to do to both sides to get K by itself? Good, so we're going to divide by 36 pi. Okay, and then, Daniel, tell me what you get when you divide. What's that? Yeah, so what happened to the pi's? Yep, pi divided by itself is just 1. 12 over 36 reduces to 1/3. That's great. And then we're going to write the function. Okay, so the function is going to be V equals 1/3 B times H. And this is the formula for the volume of a cone. Do you guys remember doing any of that? This is the area of the base, which for a cone, the base is a circle. No, you guys have blocked that out. Alright, so once you get your equation, now we can go to step 2, which is to find B, which is the area of the base, when you're given this for your volume and this for your height. Okay, so the volume equals 1/3 BH. Let's substitute in our volume, which in this case is 24 pi. We're trying to find B, and then your H is 9. Okay, so this is one again where you could divide by 9 and then multiply by 3, but it's going to be simpler to just multiply those together first. What is a third times 9? 3. So this is 3b. So I'm going to divide both sides by 3. Now notice this time there's nothing to cancel out with pi. So we know what's 24 divided by 3? 8. So this is just going to be 8 pi. So your final answer, you are going to put your units on there. Can you just tell me how I know what my units are for that one? There's a couple different ways you can figure it out. One is they tell you that the capital B means the area of the base. We know that the area always has what for the units? Squared. So it is going to be in feet squared. If you forget about that, another clue would be, see how they give you the units here for B? Okay, it's always going to have those same units. So the area of the base is always going to have units squared. The volume would always have units cubed. The height would always just have units. Okay, so no matter which one you were finding, you'd be able to figure it out. Okay? All right, I'm going to give you guys a chance to do this one once I give you the values. So for example 3, the lateral surface area L of a cone varies jointly as the base radius r, and the slant height, remember it's a cursive L, and L equals 63 pi, this is in meters squared, when r equals 3.5 meters, and the slant height is 18 meters. This says find r to the nearest tenth when L is 8 pi meters squared, and the slant height is 5 meters. Okay? So I want you to do the first step where you're finding K. So see if you can set up that equation. Step 1. So remember to set this up, I always start with what they give you first. So it says L varies jointly as the base radius r and the slant height cursive. So I always just like to keep that in mind so I know where I'm plugging things in. So K times r times L. Okay, and in this case, the L is 63 pi, you're solving for K, your R is 3.5, and then this is 18. Alright, so when you're multiplying these two together, you could set this up as your long multiplication. Is that what you guys did? Did you guys remember to move the decimal over? Did any of you do it a different way? There's a quicker way. Use what? Yeah, so I would just do 18 times 3 and then do 18 times a half, because we know half of 18 is what? 9, and then 8 times 3 is 24, carry the 2, so that would be 54 plus 9, which is, yep, so see how quick that is? I recommend doing it like that, especially if it's the half, because that part you can usually do in your head. And then, so you have 63K. Well, that worked out nicely, right? Because when you divide by 63, what are you going to be left with? Yeah. So your K value is going to be pi. So the equation is L equals pi r L. Sorry, I guess this is my function. Okay, so now for step 2, it says find r to the nearest tenth. Okay, so we have L equals pi RL. The lateral surface area is 8 pi. And then pi, we're finding R, so we're not plugging anything in there. The slant height it says is 5. Okay, so again, if you want to multiply those together first and write them like that, that is fine. You can also just divide each side by what to get R alone. And yes. Okay, so that way pi divided by pi, 5 divided by 5 will be R, pi divided by pi. So I have 8/5. Okay, now it says to round that to the nearest tenth, but this doesn't have to be a difficult thing. If you have 8/5, right, how many times does 5 go into 8? One time, with how many left over? 5ths. We just leave the bottom the same. Now, if I want to turn 3/5 into a decimal, so I know this is going to be 1 point something. Do you guys have any strategies you can think of for turning 3/5 into a decimal? Yeah. How do you know that?
Because
Do you know that 1/5 is 0.2? Is that how you did it, or did you do it differently?
1/5 is 0.2 because 5 goes in the hundreds.
Yeah, yep. You can think of it like that. Another thing you can think of is, what place is this? The tens place. So if I want to know what it is in the tens place, what could I multiply this by? Yeah, so if I multiply by 2 over 2, see how it's 6 over 10? 6/10 is 0.6. I know some of you do know 1/5 is 0.2, just from dividing that. So you could also just times that by 3 to get the 0.6. And then this would be in, meters, not inches, right? Meters. Were any of you thinking to do it out of 100? Because you could do that too. You get 60, be 0.60. And then if you rounded that to the nearest tenth, it would just be 0.6. Do you guys have questions when you're in that? Do you remember that that's the tens place? You could do the hundredths as well. Okay? And then just round it. All right, so, all right, the last one we're going to do is inverse variation. Do you guys have any guesses on what the equation is going to look like? It is. Okay, so inverse variation says y varies inversely as x. This is represented by the equation y equals k over x. And again, it always is going to stipulate that k cannot be 0. Because if it was, this would just be y equals 0. It would be a horizontal line, and you wouldn't have that variation. Okay? So this is called inverse variation. We're going to put that in our info box so that when you're doing your practice, you can go right to there. And you guys have never graphed anything with x in the denominator. It's a special type of graph. We're going to talk about that. All right, so you're given y varies inversely as x. So we're going to write and graph the inverse variation function. Step 1 is to find k when y equals 4 and x equals 5. So now we're going to use this function. Can you guys plug in the x and y and think about how you're going to solve that? So y is 4. X is 5. How do we solve for k? Yeah, you're going to multiply. So you always multiply by the denominator. So your k value is 20. So then your function is y equals 20 over x. Okay, and you do need this function Okay, you need that to graph. Now, when you graph this type of variation, there's going to be two different steps. Okay, so we're going to graph by making a table of positive values and negative values. So we're going to make two tables. I mean, really, you could make one long one, but this graph is special, so you're going to want the two. Okay, so when you have a variable in the denominator, the type of graph it produces is called a hyperbola. So not hyperbole, not an exaggeration, but remember how quadratic is called a parabola? So this is a hyperbola, okay? This has two branches in it, okay? So there's two different parts of this graph. Now if I'm doing this without a calculator, I want to pick values that are easy for me to compute. And then I have a 10 by 10 graph here. So I'm going to do the negative values first. I'm going to start with -2 because I can divide that easily. What's another value that would divide into 20 easily? 10. -10 is one. Yeah, I heard -4 and -5. So then for the positive, we're just going to do the positive values of the same thing. Okay, so 20 divided by -2 is -10, and then look, this is just the opposite. So divided by -10 is -2. 20 divided by -4 is -5, -5, -4. And really, if you look at this chart, -2 and -10, don't they multiply to +20? Yeah, so you can just check that really quick. All right, so that's how I would think of this one. 2 times what would be 20? 10, 5, 4, 2. All right, so we're gonna plot these points, and then I'm gonna show you how to connect them. Okay? So this is -10. So this one is -8, -7, -6, -5, 2, 3, 4, 5. This is just going to help me with my graphs. I know where 10 is. Okay, so for the first one, I have -2, -10, -4, -5, -5, -4, -10, -2. Okay, so you have these 4 points. Now these 4 points, we're going to connect them with a curve. I did a good job last hour. Let's hope I can keep my streak going. All right, and then draw your arrows on each end here. That's part of the graph. Okay, now we're going to draw the other branch. So we have 2, 10, 4, 5, 4, 10, 2. And again, you're connecting those with a curve. And if you do this correctly, your branches should always be in opposite quadrants. So 1 and 3 or 2 and 4. You guys remember the quadrants? No, probably. Yep. It's been a while since you heard that term. Okay? Good. How do your hyperbolas look?